Hi everyone, welcome to my channel. And today we are going to discuss about parameterized ambient multiplexes. So for all our modules so far that I have discussed, they had fixed width and fixed outputs, okay, of inputs and outputs. But we can also add a parameter in Verilog, and so that we can create n bit encoders, decoders, and can be used to create n bit circuits. So for this example, I am going to create a 4:1 multiplexer using 2:1 multiplexer, but the input and output bus will have different widths. Okay, so let's proceed with the development. I've created two files already. You may also do so. You need to create two modules, mux2 and mux4. Basically, mux2 stands for 2:1 multiplexer, and mux4 stands for 4:1 multiplexer. I'll be providing a parameter to mux2 in this format: hashtag parenthesis parameter. I'll give it a default width of 8. Okay, so by default my input bus will be of 8 bits. So I can use the parameter named width now. So I'll add this input width -1 to 0, width -1 to 0, a1, a0. Now select line of 1 bit. So input S and output of same width. Y. And I'll need to use the blocking assignment here. So assign Y. When S is on, output should be A1. Otherwise that output should be A0. Save this file. Your mux2 is now parameterized. Mux2 is now created. Now we'll create module for mux4. Let's say this input is having of 12 bits, so 11 to 1, 11 to 0 actually, a3, a2, a1, a0, input, select line of 2 bits, and output will be now same 12 bits, so 11 to 0. Okay. As discussed in previous lectures also, I used wire for declaring M1 out and M2 out, so we'll do the same thing here also. So wire of 12 bit, 11 to 0, M1 out, M2 out, okay, and we need to instantiate mux2 here. So mux2, now your input bus is of 12 bit, so you need to provide you need to make mux2:1 understand that input is of 12 bit. So we'll first instantiate this mux2 and then provide it parameter of width. First argument is a3, a2, s of 0, lower bit, select line, and output should be mapped to wire M1 out. Okay, but how the mux2 knows if it is a 12-bit line? So we'll add a parameter like this and state it is at as 12 bit. Okay, I hope this step is clear, and rest steps remain the same. Just copy this, paste. Instantiation will change. Now this is M2. A1, A0, M2 out. Similarly, the final multiplexer is also having a 12-bit bus. Final multiplexer called M3 that will have a wire M1 out, M2 out, select line of higher significant bits, so S of 1, and output is assigned to Y. Okay. Now we have designed a parameterized and a 4 is to 1 multiplexer bit and bit input bus, and where n is equal to 12. Okay. So save this. Automatically hierarchy will be created, and we can check for syntax if any error is present. Okay, no errors. We can proceed with RTL schematic. Okay, the RTL schematic is now created as shown. All inputs are of 12 bits. Okay, output is also of 12 bits with 2 bits select input. We can also expand this to see internal circuit. The circuit remains same as in previous lectures. Okay. However, the input got changed to 12 bit for 2 is to 1 multiplexer. This is also 12 bit and output is 12 bit. Okay, and this can also be expanded further. You can see the data lines are of 12 bit and output is result is of 12 bit. Similarly, the final multiplexer may also be expanded. And yeah, this is how we created a parameterized input bus and designed a 4 is to 1 multiplexer using 2 is to 1 multiplexer. So now you may provide a 12-bit input or an n-bit input also. So yeah, this is how we create parametric modules in Verilog. You may create other modules also using parameters. Okay, that will also help the designers to debug circuits easily. Okay, this is it for the video, and this may be the last lecture for this digital design series using Xilinx IC. If I get some encouragement, I'll create some more videos also. So please give your suggestion in the comment section. Okay, and let me know if you have any doubts. Okay, thank you.